Welcome all to my channel. Thank you for joining and watching this video today. You might look at this and say, wow, this is long. Do I really want to sit and watch this thing? I agree it might be long. I've watched a lot of long videos on this subject about the flat Earth versus the globe Earth. I think this is very informative and will be very informative to anybody that actually sits down and watches this and tries to digest what I'm trying to say. I've been looking into this controversy, this flat Earth versus globe heliocentrism. I've been looking into it for, I don't know, a little less than a year now. And I first set out to prove it's a globe. Because I thought that flat earthers were idiots. Like, come on, really? How can you guys say this is flat? It's not possible. Well, as if I have dived into this more, I've learned a lot about flat versus globe, perspective. I've learned about looming and refraction and distances and curve of the Earth, the drop of the Earth. I've done a lot of math. I've done a lot of calculations. I've watched a lot of videos. I've done my own research. I've probably gone out 30 different times to take pictures, to look at my horizon, to look at what I can actually see, and I've come up with some conclusions on days that my first conclusion was it's a globe. But then I've looked at things other ways and said, now wait a minute, if it's a globe, that doesn't really make sense. So I've got to look into this further. And so if you've watched any of my other videos, I've done a lot of stuff out here on Utah Lake. As you look at my screen, Utah Lake, I've looked across trying to see some buildings here. And I've got a lot of comments that say that that's not far enough. If it's a globe, you're not going to see the curve of the Earth on a 7-mile or 11-mile or even 20-mile lake. It's going to be flat. I said, well, I don't know if I believe that. I believe water is going to curve on the Earth no matter what size that water is. That's just the way it's going to work. And so I've decided, well, I've been wanting to do this for a long time, but I finally got the opportunity to look across a much larger lake, and that's the Great Salt Lake. You can see it's much larger. This body of water is much larger than this body of water. And the problem here is, I've been wanting to get some pictures for, I don't know, 8 months trying to look across this lake, but the problem is it's so hazy here 90% of the time that you just can't see. It's just too far, it's too hazy, you just can't see very far out here. Well, a couple weeks ago I was able to get a clear day, a very rare clear day after a storm that blew all of the crap in the air out, and I was able to see over 100 miles. And so I've got these couple of locations that I went to. First location I want to talk about here is up on this mountain called Suncrest. The peak up here where I set my telescope up, set my cameras up, was about 6230. Okay, you can see that the elevation down here. About 6230 is where I took that from. And looking out, and at this point, you can do the measurements. This point out to these mountains out here, we look across, is about 125 to 130 miles. So averaging it out to that peak, looking at that is about 127 miles. Okay, and so 127 miles, you're going to get quite a curvature drop. A lot of people saying it's not over land, but I'm sorry, if the Earth is round, the land is going to curve in 120 miles. It's going to happen. If I'm looking at this elevation, looking at that elevation, you should be able to calculate it because we're all going from sea level, and 100 miles is going to be 6,000 miles different, 6,600 miles if you want to be exact, different from one point to the other. In any event, so I went to that location, looked across to see the mountains. I've gone to this other location, and I've done this many times. This isn't just one day. I've done this many times, and I finally got a day where I could actually see because the haze wasn't so bad. And so here, I went to this other location, which is 6,690 feet. Problem with anywhere in between here, this is a high point right in here. The elevation gets up to 5,000 feet, and then it starts to drop down. So anything over this way, well, you're too low, and you won't be able to see the mountains because your horizon, arbitrary horizon, is this higher elevation. So I was able to go to this location here and look out, and that's 4690. I'll go into this a little bit more in greater detail. I just want to show you these locations I went to, and then I went down to right on the lake, taking one here, 4223, 4208. This is all sand, and then the level of the lake is right here, 4,200 feet. You guys can all go verify that, verify how you want it, ever you want to do that. Okay, so that's where I'm taking my elevations. And then I come across here to this mountain peak, and I say, well, what's my highest point on this peak, on these mountain range? And you run over 9,000 feet, 91, 92, 93, 88. You run along these peaks and see. Well, I found at this point is about the highest that I could find. And I found it around 9950 is the highest point that I could really find. 90, 55, 94, 50, 90, 9950, somewhere in there. Okay. You look at these, 94, 196, 97, well, that's 99. So that's the highest point on this mountain. So what I've done is, you can go to the Earth curve calculator and figure out how many your eye height and your distance and see what your target eye height needs to be, or your target object height needs to be. And so I've made this little spreadsheet here just to kind of illustrate that. So I telescope locations of the elevation, and then the elevation of the lake, and my equivalent eye height. My equivalent eye height would be, this minus the lake, the telescope location, minus the lake level, plus 6 feet, because I'm about 6 feet tall. I'm just rounding up. I don't know, 5.5, my eye level, whatever. I'm 6 feet tall, 6 feet. So my eye height's 14 feet, 31 feet, 496 feet, and 2,036 feet. And at each one of those, the distance, and the nice thing about Google Earth is if you click on one of these lines, you can just click on a line, and, oh, that's the wrong line. I'm talking Maui. Suncrest to George Peak, you can see that line disappear when I uncheck it. You can go to the properties, to the measurements, 130 miles. So you can see how far each one of these distances are. So I've done that to get the distances to the mountain. So distance, 100 miles, 100 miles. This is really 100.13. I don't care, it's 100 miles. That distance, 110, 127. So if I put that into my Earth curve calculator, I get this target hidden height of 60, 70, 57, 89, 45, 63, 34, 32. Which means if I add this number to my lake elevation, because that is my arbitrary horizon, because I'm not at sea level, that's what I need to start from, and then add these numbers to that. That means if I'm standing on top of Suncrest, I should be able to see the mountains from 7,600 feet and up, because 3,432 feet are going to be below my horizon. And remember, my peak is 79, so I should be able to see, this is the highest peak, I should be able to see 2,318 feet of that mountain. Okay? My next location, 4690, do all the calculations. My hidden height needs to be 8,700 feet, which means I should be able to see 1,200 feet of that mountain. So these two pictures I should be able to see kind of are different. And I can see this much, and then I can only see this much. And then when I come down to this other location right at the lake level, I do the calculation, and I come up with the elevation that I need to see is 99.89. Well, anything below this elevation I shouldn't be able to see. Well, if my peak is 99.50, that means the entire mountain range should be 40 feet, 39 feet below the horizon. I should not be able to see it whatsoever. I shouldn't be able to see any of the mountain. Now you talk about looming and refraction. Well, that's a globalist's theory on why you can see something that's further away. Get into that in another video. If you want to go look up looming and refraction and all that, go for it. I've looked it up. In any event, it should be 40 feet below the horizon. The next thing is right at the lake, 14 feet above the lake. That should be 320 feet. The highest peak should be 320 feet below my horizon. I should not be able to see it. Okay, so if I go to that location, yes, I can see it. That location, yes, I can see it. That location, no. Location, no. Okay, so the first location there, yes, I should be able to see it. I'm agreeing with everybody on a globe Earth. I should be able to see it. Even here, I should be able to see it. These two locations, shouldn't be able to see it at all. So I was finally able to go out and take some pictures that I could actually see, because the haze had been blown out by the storm that came through. And so I could actually see further than 50 miles in the valley. And so I went out and took some pictures from these locations. Now this is just taken from, this isn't even from my telescope. This is just from my Canon camera with a 75 to 300 millimeter zoom. So it's a fairly good zoom, but it's not spectacular. It's not a telescope or anything. But if you look at this picture here, you can see this mountain out there, which I'm not denying you shouldn't be able to see. I believe you should be able to see it. But I believe you should only be able to see, if we go back to this, 1,200 feet of this mountain. If we go back to this mountain range over here, and we look at 1,200 feet down from the peak, we come down so you can kind of see what I'm looking at the same place as my picture. You know, we kind of zoom in. Well, if I take 9950 and I minus 1,200 feet off of that, that's 8750, right? So I come down to 8750, which you guys can't see because my screen. If I come down here now, you can see the elevation of my cursor. Well, my cursor, 8,700 feet, is right here. 88, 87, 86. You can kind of draw this line that goes around these mountains at 8,600 feet and say, well, I shouldn't be able to see anything below this point, right? Even over here, I mean, 8,600 feet is clear up on top of the mountain here. Same thing if I go over this way, 8,600 feet is clear up at this elevation, right? You can't see any of this down below. This is all going to be below the curve of the Earth. But what does this picture show? 8,600 feet should be just off of these cliffs right here. There's about, and this line right here should be about 8,600 feet, and everything below that should be below my horizon. But if I look at this, this is the lake. This doesn't look like the real horizon, and stuff is, you know, below it. It's just not the case. You can see that entire mountain. You can see clear over here. You can see clear down to the bottom. So I took a bunch of pictures with, this one's not zoomed in. So this is just my regular lens, not zoomed in at all, zoomed all the way out. So you can see this mountain go all the way down to the water level, basically. So I took a bunch of pictures just to kind of show where I was at, show across the other. This picture is actually looking across this way, and you can kind of see these mountains actually back here. If you look close, you see these hills back in the back, way back here. That's what those are. Anyway, that's just kind of, you can kind of see the haze. The haze is starting to build in again already. You can kind of see it out there. But anyway, you can actually see farther than you normally can because the haze has cleared away. But so you come back to this mountain again and say, I can see this entire mountain. Where is this dip here? I mean, if you look at that dip and the elevation of that little dip in the mountain. Oh, sorry. And the elevation here is 9,000 feet. So I really, at that location, I should only be able to see 300 feet below that dip. I can see a lot more than 300 feet below that dip. I mean, you can see the brown, you can see the land all the way across here. And then what I did is I went to the next location. Okay, I dropped location, and I went to right off the lake. Okay, right off the lake at this location right here. Okay, and the next pictures will be from right here at 4223 feet. Okay, so I went to this location. It's 4223, 4225. I used my 4225 from 31 feet off at 100 miles. My target hidden height, 5789. That means the mountain should be 40 feet below the horizon. When I went out there, This is a picture from my Canon camera at that location, and you can see the mountain out here. Granted, it's shorter, it's smaller, but you can still see the same features. You can still see this feature, this hill here. You can still see the same features in the picture as you could back here. Okay, it's still the same features. So we are definitely looking at the same mountain. But it's interesting how much shorter it is. I thought that was very interesting. And a lot of people are saying, well, that's getting cut off. That proves the globe. That proves you can see only a portion of the mountain. And I'm saying, no, it actually doesn't. Because what you're seeing is perspective. When I'm down lower and I'm closer to the ground, you can still see this black line. You can still see the land in front of the snow-capped mountains and behind the water. This is the water. Here's the land in front. It goes up. What is interesting, though, is the whole thing has been kind of squished a little bit. And I think that's due to perspective and the way that where you're looking from is a lower point than I was previously. And so as that land, 30 miles of land or 20 miles of land goes up very, very gradually, well, now when I'm really low and I'm looking at it, I'm kind of looking just flat straight across it, and so you don't see it rise up at all. And so when I'm up at a higher location, when I'm up at this other location here, I can see more land because I'm up higher and I'm looking kind of down on it. And it'll rise up, just like when you're at the ocean and you're looking down at the ocean rises up to your eye level. Well, this land is kind of doing the same thing. It's still rising up, and I can see all the land here. But when I'm down at a lower location, I'm looking more straight on it. Just like if you go to the ocean and you drop your eye level down, well, now that ocean is getting smaller and smaller and smaller and getting kind of squished. And that's what we're seeing here. It's getting squished. There is one photo I wanted to show. I kind of looked at Photoshop and was looking at comparing those two pictures I took there from the first location and then the other location, and I kind of just enhanced the lighting and stuff just to see a better shot of this. But as I turn on these different layers, you can see, if we kind of zoom in a little bit here, here's the same features here as they are here. Now this is the level of the water when I'm down lower. Okay, that's the level of the water, and that's how big the mountain is. But you can still see everything is still there. It's just a lot smaller. Okay, everything is still there. You may think this is all behind and this is where the line really is, because you're only seeing that much. But I beg to differ, because if you start looking at the different features, you look at this, and you look at this, you look at these different features, and you trim that off, that layer off, my mouse would move. Those features are all still completely there. They aren't cut off. Kind of go back and forth a little bit. You can see how it stretches it out wide and squishes it down to where even this right here, this piece right here is flat. It kind of goes out like this because I'm looking at a different angle. I'm looking kind of up at it rather than down at it. And so that is all still there. It's all still here. You can see it's just looking at a different angle. I'm still seeing this. It's just up here now. And so the other thing I did is I said, well, we'll kind of squish it. And that's kind of this is this same picture right here that I took, but then I kind of squished it to kind of match what I was seeing here in this one. Okay, that's kind of more what I'm seeing. I'm not seeing any less. I'm just squishing it down where I'm looking across. Don't know if that makes sense to anybody. If anybody else wants to do more analysis of these pictures, feel free to contact me. I'll send you the pictures that I took, and you can do all the analysis you want, full-size picture, not just looking at a YouTube screen. In any event, that's all I wanted to show there. is those couple of pictures. So anyway, let's go back to this picture here. And let's look at these other pictures that I took. So I took a few pictures here just kind of show that I can still see that around. Just kind of showing my view, the whole thing. Zoom in, you can still see it. That's what I'm doing, just zooms out. But then I went out onto the sand itself. You can see here, so I was first right here just on the mountain, and I walked out here and put my telescope right on the sand, right out here. So that's where this is from. So here's my telescope. It's about 5 feet tall. I just called it 6 feet. Again, I'm just using my Canon camera here. This really isn't focused on the mountain. I was focusing on this. But you can see the mountain still out in the distance. I'm actually lower. You can see I'm lower than actually 5 feet. So it should actually be even further down, further behind the curve. So I just took a few pictures just to kind of show, okay, I got my telescope here. This is right at the telescope eye level. Looking at these mountains again, looking at the same thing that I took just a few minutes ago. Again, just taking some pictures to kind of show different views, different angles, but I'm seeing the same thing every time. Again, this highest peak is actually right in here. I think this is just barely lower than that. But again, this is 99.90 or 99.50, which should be 320 feet below what would be considered my horizon right here. If you think your horizon is 5 miles out there, if you're 14 feet above the water. Anyway, that's just a few more pictures, kind of to prove where I was. There's some people out there out at the lake enjoying themselves. This is the Great Saltaire. If you want to just look this up where I was. This is where I was standing here, parked over here. This is where I was standing before taking those other pictures, and then just taking some pictures around to see the different, just kind of show you where I was. Again, this is looking out. This is Ben Lomond. Actually, I think Ben Lomond's actually over here, looking towards Ogden, Brigham City, Tremont, up that way. So, go back into that picture in just a minute. So anyway, we go back to these pictures. You can certainly see, even when I'm not even focused on that, you can still see the mountains, which I think should be completely behind the curve. Should not be able to see it, even with, let's say, some looming and say some light refraction. Let's say you're able to see a little bit more than you should. Do you really think you should be able to see the entire mountain? I know that's not a very good picture to look at. Let's go back. You really think you should be able to see down this far? I mean, you see this dark line. This is land. This isn't a mirage. This water still right here. This isn't a mirage, and this mountain's looking up above. I'm sorry. It's not it. It's not a mirage. I saw it with my own eyes. It's not a mirage. This is water, and then the mountain behind it. I mean, go back to these other pictures before. Same thing. Goes the water. There's the land. And anyway, so the next thing I did is, so that's those two locations, which in my mind I shouldn't be able to see at all. But then I went back to my Suncrest on top of the mountain here location just to see what I could see. And these pictures here, these were all taken the same day. From this location, those locations, and this location was all taken the same day. Now this one was a little bit later in the day. The sun was actually going down, so I didn't get quite as clear pictures and as good as pictures as I wanted to. But I had to work too. So anyway, this is in between some errands that I was running that went and took these pictures. But anyway, so now I'm up on top of the mountain, looking across the valley. Where I was taking the pictures before was about right here, and then a little bit further out. Some people say, well, that's just a cloud layer out there. This is a cloud. I will give you that. This is a cloud right here. But this is the water. This is what it is. And then you have the mountain out here. Which I agree. I'm not disagreeing with anybody that I shouldn't be able to see that. I think I should be able to see this mountain out here. But I should only be able to see 2,000 feet of that mountain. Not 4,000 or 5,000 feet of that mountain. This is, again, the water. This is kind of a little cloud haze layer that's starting to build up again. You see that as it comes across and it's kind of above the land. It's kind of, the mountain goes right behind the little cloud layer right there. This is the mountain range. Again, zoomed in a little bit better. You can see a little bit better. This is all land here. Goes up. And I'm sorry. This just from here to there is not only 1,200 feet. If it's 1,200 or 2,000 feet, if that's the case, 2,000 feet. 2,000 feet. I should only be able to see to 7,900 feet, which would be somewhere in here, right? Somewhere in this location. So I think this is evidence. This is evidence of more of a flat Earth. I don't think the curvature, if it is curved, is correct. What they're telling us, and if that's not correct, then everything is a lie, because then the 24,000 miles circumference of the Earth doesn't make sense with traveling 1,000 miles an hour to make 24 hours a day. You know, if the curve isn't the curve, then what is the curve? What really is it? And I think these pictures are proof that you can see a lot further than what they say you should be able to see. You can see the whole valley here. This is from this point to those mountains, 127 miles. Do your calculations. Do the Earth curve calculations. Sorry, I'm just taking some sunset pictures, trying to test my camera and stuff. But, you know, do some research yourself. This is pretty good evidence in my mind. Now, I got to go show you the pictures that I took with my telescope, just for kicks and giggles. So let me find those real quick. So that was with a Canon camera. I took some with another camera, and then I took some with my phone through the telescope, like I've done in the past. I don't have very sophisticated cameras and stuff, but you know, just taking these pictures through the telescope, I think sometimes. So I actually had two different telescopes. This was my old one that I originally had, which I think is actually a little bit clearer than the newer one I bought. But I took some videos and pictures, so you can see this. These are the same features I took with my Canon camera. This is kind of the video that I took. It's really hard, and I know shaky and hard to see. But let's get to the other one. So this one actually I just took with my phone, kind of zoomed in. Just my iPhone, no telescope or nothing, just looking at those mountains. This isn't even zoomed in at all. This is just taking my picture with my iPhone 6, and you can actually see the mountains with that kind of resolution. Pretty interesting. So then I went down here again. This is right down off the water on the road. You can see the mountains out here in the distance. Took some pictures again through the telescope. Kind of the same thing that I took with my Canon camera. It's actually amazing. My Canon camera is as good as it is. Don't really even need my telescope for a lot of this stuff. I just use my Canon camera, but I just wanted to show you this too, the telescope that I was using to look across, getting the same pictures I got with my Canon camera. So I took a lot of, I mean, you can see, again, this is a pretty good one. You can see those features. You can see the land out in front. Granted, it's going to be a little distorted because I'm looking through a telescope with my phone. I mean, it's not going to be a perfect picture by any means, but you can see what's going on. So there's the one telescope here. This is my other telescope, my newer telescope, which is supposed to be a little bit better. I don't know. I don't think it focuses quite as good, but you know, you guys can look and see what you guys think. There was a better video that I actually had of that. I want to go to that one. So this one here is pretty decent footage of it. Seeing the mountain across there. So here's just another picture I took with my phone, looking out where the telescope is, where I'm located. You can see the mountains back here in the distance again. Just kind of showing where I am, what I saw, looking through the telescope again, right 15 feet above the shoreline, looking at the mountains across, which I don't think you should be able to see whatsoever. Sorry, I know getting this to line up is very difficult. I wish I had some better equipment to do that, but I don't. And I don't think I'm going to go spend any more money on this because I've pretty much proven to myself what I set out to prove. I set out 9 months ago, 8 months ago, whatever it was, to prove to myself what the curve really is and do the calculations myself. And I think I've come to the conclusion that we've been lied to, and it really isn't round. I mean, if they're telling us what the curve really is, and that's what we believe it to be, this should not be possible. I should not be able to see what I'm seeing here. Just took a bunch of pictures, just kind of showing where I was. In any event, those are all my pictures. You can see them all. I'm scrolling through them all. Nothing's been altered. Nothing's been documented or doctored in Photoshop. I've taken all these pictures, just they're authentic pictures, non-doctored. Looking at this mountain range on the northwest side of the Great Salt Lake from these locations here. If you want any more information on these, feel free to send me an email, send me a message to ask any more questions you want. I've done a lot of research. I've taken a lot of time doing this, and I think I've come up with my conclusions. And people said that looking at Utah Lake isn't good enough, and so I've taken it a step further. Finally, when I've actually got some time and the actual right conditions where I can see that far, and I think I've proved to myself, if not, hopefully a few of you others out there, that I'm seeing what I should be seeing, and the Earth is flat. One last thing I just wanted to show. It's pretty interesting. I was up on this peak here back in November, and I can see from this peak clear over 135 miles to this peak, and also over to this peak. It's pretty cool because standing from that point, you pretty much can see from one end of Utah to the other, and seeing from here up to there, it's pretty amazing. You'd think you'd be able to see some curvature. I understand people think, oh, the world is so big you can't see the curvature, but I think if you do the calculations, you do the math, and you really look at it. I've actually done a AutoCAD drawing here where I've drawn this Earth to scale. This is actually to scale. Got two lines here. This white line is actually at sea level. The blue line is at 4,200 feet, the lake level. And what I've done is I've actually drawn a line here. So if I'm at the lake level, this yellow line, oops, let's do some panning here. This yellow line would be straight level from 4,200 feet right at the lake level across 100 miles. And the blue line, that should be the curve of the Earth. That's how it's curving here. It comes down, and this is 100 miles. So this brown line here, if I take in the curve of the Earth, take the 4,200 feet plus 5,700 feet to get up to my 9950 feet, somewhere right in there. This line here, this is the peak. This is where my mountain should be, and this is where my level is. So in anything, if I'm looking level, completely level, I would look over the mountain. I actually have to look down in order to see that. And I don't believe I'm looking down. One day I will get a level, and I will do more experiments that way with a level, and actually seeing if I can see from this point to this point, and what the elevations are, and if I'm looking up or down or level. But what's interesting is you take this brown line, so this brown line that goes horizontally this way, that is my line looking from where I am looking at 14 feet above the water to the top of the mountain, to the peak, on a globe Earth, right? So I'm looking there. Well, what's interesting is this brown line, if I zoom in here, is actually goes below the blue line. Remember, this blue line is the water lake level. This yellow line was looking straight across. It's the horizontal line off the Earth, a tangent line from where I'm standing. And this is my eyesight. If I come back out, zoom back in, you can see this pink line is 13, 14 feet. I think I did 13 feet actually. 13 feet. And then I'm looking out, and there's my brown line looking out across, and it actually goes, there it's above, it actually goes below the blue line. So in theory, I shouldn't be able to see that mountain because I'm looking through the water. I've done a lot more other calculations and with the Earth, and I've got actually quite a few different CAD drawings that I've done to different locations, different places. I'm not going to bore with anybody here, but the next thing my next video I want to do is actually this one to the moon, which is very intriguing to me on the location of the moon. Why is that not opening up here? Location of the moon, close that one, to Earth. Oh, there's the sun. Big sun, huh? This is not to scale. The distance here is not to scale. This is just a representation of how big the moon is, not to scale, but then this Earth is to scale and where the moon is. And I want to get into another video on the angles of the moon in the summer and in the winter, and where it should be in the sky relative to where I am in Utah, and what the degrees really should be. So look for that video. Hopefully I'll get to that one soon, and you guys can look at the moon with me and try to figure out the angles, because I am really puzzled on the angles of the moon and where it's really located in the sky and where they tell us it should be. It doesn't match up, in my opinion. So anyway, that's my take. I hope you all watched the one that I did about Oahu. That was a pretty cool video. I think this is pretty good evidence, looking 300 miles from that point to that point of the guy that took the picture, seeing all that. If you haven't seen it, click on my other video, the Oahu to the Big Island video. I think that one is very convincing and evidence of a flat Earth as well. If you have any comments, let me know. And if you, like I said, if you want these pictures, feel free to send me an email or send me a message. Let me know where I can send them. I'll send you the pictures so you can do your own analysis of stuff. Thanks, guys, for watching. I hope this was informative to you all. And again, 9 months ago, I would have laughed at somebody that said the Earth is flat. I would have said, whatever, dude, you're wrong. I did. I mean, I did say that. That's what got me into this. And the more I've done the research, the more I've taken the time to do the math, the more I've taken time to do my own observations, my own calculations, not just taking somebody's word for it, not taking somebody's word for what a mirage is and what you're really seeing, and really trying to understand what you're seeing when you're closer to the horizon. Things are going to be small. Looking into perspective, looking into your eyesight, looking into those things, I think it opens up people's minds, and I think we need to be aware of what is going on around us and not just take for granted what somebody says to us. You know, somebody can say something, that doesn't make it true. Do the research. Look it up for yourself. Am I going to make a difference on whether everybody believes the Earth is flat or whether they believe it's round? I doubt it, but I'm just putting the evidence out there for people to see. Anyway, good luck, good night. Stay tuned for more videos.